Hi, my name is Daniel Plaisted, and I work on the .NET framework at Microsoft. In this video, we'll learn how to create cross-platform apps using portable class libraries. We'll learn what portable class libraries are, and we'll see some patterns that are useful when using them. And then we'll take what we've learned and create a simple cross-platform app. Portable class libraries are .NET libraries that can be used from multiple .NET platforms. When you create a portable class library in Visual Studio, you can choose which platforms to target. And then you can reference and use that library from projects targeting any of those platforms that you chose. When you use portable class libraries, you need to separate the code that will be shared between platforms from the code that will be platform specific. So we'll look at a few patterns that help you do this. The first one is the Model-View-ViewModel, or MVVM pattern. The MVVM pattern is a popular pattern to use when creating XAML-based user interfaces. And it starts with your models. These are your data objects and your business logic, and it can be any code that doesn't directly relate to the user interface. On top of your models, you create view models. This is directly related to the user interface. It references your models, and it encapsulates what information should be displayed and the flow of interaction of your app. But it doesn't say anything about how that information should be displayed. That's the responsibility of the view. The view is written in XAML, and it defines how the information from the view model should be displayed. It uses XAML data binding to link up with your view model. Now, when you're creating a cross-platform app, you want to customize the user interface for each platform that you're targeting. The platforms may have different screen sizes or UI metaphors, for example, and you want to take advantage of that. So your views should be platform specific. But in many cases, what you are going to display and the flow of interaction of your app, as well as your data objects and business logic, can be shared across platforms, and so you can make those portable. The MVVM pattern is really ideally suited for creating cross-platform apps because it creates this clean separation between your platform-specific code and your portable code. So when you apply that to a project, you end up with this project structure, where you have a portable class library with your view models and models, and then for each platform you target, you create an app which references that portable class library and includes your startup code and your views. Now, as you're implementing your view models and models, eventually you'll probably run into some functionality that's not available from portable class libraries because it's platform specific. For example, saving or loading to a file. So that brings us to our second pattern, which is to create portable abstractions for platform-specific functionality. Create an interface or an abstract class which encapsulates what you want to do and put that in your portable class library. And then implement that abstraction for each platform that you target. So now let's take what we've learned and create a simple cross-platform app. The app that we'll create will be a Notepad app. So we'll call it Portable Notepad. And we'll create a WPF version of that app using .NET 4.5, and we'll create a Windows Phone 8 and a Windows Store version of the app. Now we'll create our view models in this portable class library, and there's two interfaces that view models use to communicate with the view: iNotifyPropertyChanged and iCommand. And so we'll add some simple implementations of those interfaces to our project: iCommand and iNotifyPropertyChanged. And then we'll create our view model class, and we'll call it Notepad View Model. And this class will derive from the base class which implements the iNotifyPropertyChanged interface. Now in our app, what we'll have is a text box for the file name and a text box for the contents of the file, and then two buttons, one to save and one to load. To correspond to the two text boxes, we'll create two properties on our view model, for the file name and for the contents. And in the setters for those properties, we'll call a helper method on the base class, which will set the value and will raise the property changed notification. and that notification will let the view know when that property has changed, so it can update the corresponding text box. Likewise, for our buttons, we'll create two iCommand properties on our view model, and we'll create two methods to implement that functionality. In our constructor, we'll link up those iCommand properties with the methods that we wrote using the implementation of iCommand. So now we have everything we need for the view to bind to our view model. We just need to implement this save and load functionality. And that's platform-specific functionality that we need access to. So we'll create an abstraction for that. So in this case, we've written an iFile storage interface which has save and load methods. And because we're going to target Windows Store, the File I/O APIs on that platform are async, so we're returning tasks from those methods. And then we need access to an instance of this interface in our view model, so we'll take it as a parameter on our constructor and save it off to a field. Now we can implement our save and load functionality by calling through that interface. In our load method, we actually want to wait for an async operation to complete, so we'll make that an async method, and we'll use the await keyword. So now we have a view model which encapsulates the main functionality of our app and can be shared across platforms. So now we can see that we've created versions of this app for Windows Store, for Windows Phone 8, and for WPF. And we have our portable code here, and each of these projects references that portable project. Each of them also implements this iFile storage interface using the platform-specific APIs, in this case for Windows Phone, using the isolated storage APIs. And each of these projects also has a view which corresponds to the view model we wrote. Here is the one for Windows Phone. We can see the text boxes for the file name and for the contents, and the save and load buttons. And in the XAML here, we can see how these use data binding to connect to the view model. This is a text box where the text property is set to the file name property from our view model using XAML binding. Likewise, for our buttons, we're binding to the save command and the load command. And so now we need to create the view model and link it up to the view. And in this case, we're doing that in the constructor for our view. So we simply new up a view model and then set the data context property of the view to that view model. And that's when we can create our file storage implementation and pass it down into our portable code. So when we run the app, we can see the text boxes, and we can write something and save it to a file, and then we can load that from the file. So we have some simple functionality that we put in a portable class library to share between platforms. So to review what we learned to use portable class libraries to share code between platforms. We learned to use the MVVM pattern to create cross-platform apps and to put the models and view models in portable class libraries, and then to create platform-specific views. And we learned to create portable abstractions for platform-specific functionality and to implement those abstractions on each of our platforms. So thanks for watching, and I can't wait to see what you'll do with portable class libraries.